Hello 108 students, Mr. McCue here, picking up on section 10.4, and we're going to work on page 2 of our class notes here, and we're going to focus on objective number 2, which has got us looking at the quotient rule for logarithms. Okay, now just like our exponents, come down here and remind us here real quick, when you divide by the same base, you subtract the exponents. That's pretty common knowledge for us here now by 108 times frame. So now we're going to apply this dealing with logarithms. Okay, noticing here in my notes you must have the same base when you're working with these rules, and the form of the rule here says that if you've got log of a base b and the result is a quotient, aka a fraction, numerator divided by denominator, you can replace it with the log of the base of the numerator minus, that's the big deal here, when you've got division it's minus a log of the base of the denominator. So here was the numerator and this was the denominator. Okay, if you keep that in mind here, this rule usually you see it going from the left side to the right side, but keep in mind you could see it with two logs with a minus sign, and you want to trigger in your brain that you go back in the reverse direction and compress that back into the log of the same base, with the result having division, or the quotient of the numerator divided by the denominator. Okay, one big caution here I'd like to bring up for the class is very easy to get fallen into the trap that you simply see a result with the division in here and you want to write it as the log base of the numerator divided by the log base of the denominator. That is wrong. So make sure you try to get that out of your head and don't follow that. Over here is a real quick proof of it. If you take log base 2 of 32 divided by 8, and if you followed this trap, you would turn around and separate the log 2 of the 32, which is the numerator, divided by the denominator, log 2 of 8. And come back here and assess this real quick. 32 divided by 8 is 4, and you'd have log 2 of 4. And what you're going to do when you assess these here is you tell yourself, you ask yourself, 2 raised to what exponent, and that's what logs are all about, expressing exponents. 2 raised to what equals the result 4. A lot of times if you look at the 2 and the base and the result and put it in this format and ask yourself that question, you'll come up with a 2 squared equals 4, and that's what you're going to put as the result of that. Okay, now over here real quick, the same concept. Log 2 with result 32 says 2 raised to what exponent equals 32. Answer is 5. And finally, 2 raised to what exponent equals 8, and you would say 3. Okay, so that's a good shortcut way to evaluate logs when you've got the base and a result. You try to ask yourself the base raised to what exponent equals the result. Usually you'll see the answer. Okay, now here 2 simply does not equal 5 divided by 3, therefore there's proof that you can't do it that way. So please keep that in mind. So I have here in words, the log of a quotient does not equal the log of the numerator divided by the log of the denominator. Please don't fall for that. Okay. Now, what's interesting is I took a couple minutes here and I actually tried to prove that the the rule that we're working on here of the quotient rule is indeed true. And what I did was, an example was I took the log base 2 of 32 divided by 8, and I realized I've got a quotient in the results, or a fraction, and I separated as the log 2 of the numerator minus the log 2 of the denominator. So here was the numerator, here was the subtraction that you must need, and here was the denominator. Okay, now once you've done that, you can start to turn around and say 2 raised to what exponent equals 32, and the answer is 5. Over here you say 2 raised to what exponent equals 8, and the answer is 3. 5 minus 3 equals 2. And over here, 32 divided by 8 equals 4, so 2 raised to what exponent equals 4? Answer 2. 2 equals 2, and there we've proven it. Okay, now with that armed with us here, we could do a couple examples. Example 2a brings us down to a direct usage of the quotient rule. Notice that x is greater than 0, by the way, on these problems. That base has got to be greater than 0. Okay. Log 4 of a result that has the quotient 7 divided by 9. I always like to just look at the fractions, kind of a clear sign. You need to separate it apart and say the log of the numerator minus the log of the denominator, and that's all you can do. So you just separate them out. This was the numerator again, there was the subtraction we're talking about, and the denominator. Okay, let's try another example. Let's look at 2b. This time I notice I've got the same base. You must have the same base to do these rules. And I see the subtraction. That catches my eye. And so I could compress that and say it's the log of the base 5 that was in both of them. And in the result, I'm going to put the quotient or the fraction, the numerator 6 divided by x. So there's your numerator, there's your denominator, and you simply stack them as a fraction. And there's your answer. Okay, not too bad. Takes a little bit of practice. You get used to them. Finally, let's take a look at 2c. And we have a situation that says log base 3 of the result, which has got 27 divided by 5 in the quotient. And I realize I can separate them with the log of the numerator, which is log 3 of 27. I'm going to minus, don't forget the minus sign, log 3 of the denominator, which is a 5. Okay. And now I come down and I ask myself, 3 raised to what exponent equals 27? Answer, 3. Here's your subtraction. And log 3 with the result 5 you leave alone. Now one reason why you leave that alone is if you try to answer that question, here's 3 raised to what exponent equals 5. And if you can't come up with a whole number to put in an exponent, such as 3 to the first is 3, 3 to the second is 9, therefore this would be like a fraction, and we don't bother working with it for now. We just leave it in the log form. Okay, well that's it for page 2, class. Doing pretty good here, so I will see you on page 3.